Topic virtualization and containerization. So virtualization types discuss చేసుకుంటాం. Virtualization and containerization. Virtualization, containerization. Virtualization is nothing but so this is a process of running multiple OSs parallelly on single piece of hardware. So how will look like this means see the hardware. On top of hardware, we deployed host OS. Host OS. On top of host OS, install hypervisor. Hypervisor software. So here VMware VirtualBox and VMware, these are hypervisor softwares. After installation, what hypervisor software can deploy guest OS, multiple guest OS on top of hypervisor. Is one guest OS. On top of guest OS, who can deploy multiple applications or our multiple applications or application. So this is a this is one type of OS. This guest OS another type of OS. This is another type of OS. So you can deploy like this. This type of virtualization can be called as para virtualization. This is the guest OS. This is the hardware. So on top of guest OS, running multiple applications means see app services one application, DB is one application like that we can deploy on top of guest OS. So this type of virtualization, cloud vendors not following. See, Agile, when we are using Agile technology, Agile methodology, application process is a architecture entire. So application deployed in the form of virtualization. So in this case, some of the organizations physically some of the organization deploying applications by using para virtualization and non-para virtualization. So this is a non-para virtualization. Don't confuse. Yes. So next, cloud cloud vendor following this type of architecture, virtualization architecture. Any cloud vendor, any cloud. This is a hardware. On top of hardware, installed hypervisor. No, there is no guest OS here. Hypervisor software. On top of hypervisor, we can deploy multiple guest OSs. On top of, we can deploy our applications. See, here number of layers is reduced. That's why any cloud vendor, they are following hypervisor mission. So HVM model, they are maintaining virtualization technology for deploying applications on the servers. See, here number of layers is reduced compared to non-para virtualization. So this is a para virtualization. See, clearly understand. This is the process of running multiple OSs parallelly on top of single. So on top of hardware, running multiple OSs simultaneously in single piece of hardware. That, that can be called as a para virtualization. Here we have installed on top of hardware hypervisor, on top of hypervisor and in, installed guest OSs. Can run any number of OSs as a guest OSs on top of hypervisor. So disadvantages of this approach is a application is running on guest OSs have to pass through number of layers of to access the hardware resource. Here, if you want to access this application, you need to pass X, you need to cross the number of layers. So that's why this is the disadvantage of deploying applications using virtualization. So why containers is popular? So containers is any Docker technology is creating containers or containers and images. So containers are very lightweight. It is on top of guest OS. We can install Docker engine. We can deploy on the Docker on top of Docker. We can run application in the form of containers. So containers are OS Docker is used to see actually application on top of guest OS directly deploy applications means it is depending on specific OS. Docker is this specific dependency removed from application. So once Docker install any guest OS, application running in the form of containers means this specific OS dependency means here we have a bare metal. This para-virtualization is a bare metal. This non-para-virtualization is a non-bare metal. We can call like this technical words. So we have bare metal on top of which we installed host OS. On top of host OS, we installed application called Docker engine directly host OS. This is the guest OS. We can call the host OS. So on top guest OS, we can install Docker. So on top of Docker engine, we can run any applications in the form of containers. So Docker is a technology for creating containers on images. Docker achieve what commonly called as process isolation. That is nothing but all the applications processes have some dependency on specific OS. If you install directly on guest OS application, it is application have specific dependency related to specific OS. So that dependency removed by Docker. So, and we can run them on any OS as a container. If you have Docker engine installed, once Docker engine installed, we can run any OS, run in the form of containers. These containers pass through less number of layers. Here, directly communicating after installing Docker, containers communicating only the guest OS. In the guest OS resource, what are the resources available? Those resources be accessing. So less number of layers to access hardware resources. Also organizations need not to spend money specific license related to specific OS to maintain by various applications. So this is one of the best advantages when you go for containers. You need not to buy any license and all. If you want to buy a Red Hat OS, you need to take a subscription per yearly. So there is a community support is there, but you need to spend a lot of money for that. So when you depends on Docker containers, no need to spend this kind of money. It is going to save cost optimization and all. So Docker life cycle, three stages: build, ship, run. Can discuss the build and what is the ship and so virtualization. This is the virtualization. So we need diagram for how will Docker interact with the containers related architecture, hardware. Sir, sir, hypervisor software. Hypervisor software. Install host OS. 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 On top of guest OS, we can install Docker engine. So here we can deploy application in the form of containers, right? So like this, we can deploy the application in the form of containers. After installation Docker engine, it is application dependency removed by Docker. So containers directly interact with the host OS or hardware resources, not these background layers. So that's why application performance is better than host OS. This is the containerization. Topic. So Docker life cycle. So some more feature you need to understand virtualization. So while virtualization offers numerous benefits such as improved resources utilization, easier management and flexibility, it also introduced some overhead due to additional layers involved in accessing hardware resources. This overhead can load to reduce performance compared to running directly on the bare metal, especially for applications that requires low latency, high throughput. However, despite the overhead, virtualization is still widely used in various scenarios due to these advantages. Some common best use cases of virtualization server is the one use case of best use case of virtualization. So server consolidation is nothing but virtualization allows multiple virtual servers to run on a single physical server. So reduce hardware costs means on top of guest OS we install this hypervisor on top of we install guest OS, right? It it is reducing cost. That's why understand. So this is a particularly useful for organizations with large number of servers that are underutilized. So next use case, development and testing. So virtualization provides a convenient and cost-efficient way to create isolated environment for software development and testing, debugging. So again, I am repeating. So virtualization provides a convenient and cost-effective way to create isolated environments, such as for software development, testing, and debugging. Developer can easily set up multiple virtual machines, means VMs, or EC2 machines. So depending on the cloud providing component names. With different configurations, test their applications across various platforms. So different platforms, their application based on application requirement, they are using configuration methods. So this is also best use case of virtualization and disaster recovery. One more virtualization best use case, disaster recovery and high availability. So how virtualization providing disaster recovery and high availability? Virtualization enables organization to implement robust disaster recovery and high availability solutions by replicating virtual machines. Replicating means, see, on top of hypervisor, you can replicating multiple guest OSs, right? That is the use case. But virtual machines to offsite locations or running redundant VMs on separate physical servers. This ensures business continuity and minimize downtime. So when you are deploy when you are using multiple replicas, it is reducing cost and ensure this business can continuity and minimize downtime. So automatically when servers increases means load balancing. So application performance automatically increased. That is saying minimize downtime. In the event of hardware failures and disaster. So whenever hardware failures happen under disaster, so we will take backup from these scenarios. So next use case, legacy application support. So virtualizations allows legacy applications that requires older operating system. So specific configuration to run on modern. So by encapsulating these applications in VMs, organizations can maintain compatibility without the need for a dedicated legacy hardware. So this is kind of support available in virtualization. This is kind of future legacy application support. See here one more time I'm repeating. Virtualization allows legacy applications that requires older operating systems. So specific hardware configuration to run modern hardware. And by encapsulating these applications in VMs, organization can maintain compatibility without the need for dedicated legacy hardware. So this kind of features also virtualization providing. Next, desktop virtualization. Desktop virtualization is nothing but what virtual desktop infrastructure, VDI. Short name is a VDI. Enables organization to centrally manage and deliver desktop environments such as compute instances, storage, and networking. So cloud providers use virtualization to achieve multi-latency and scalability, resource isolation in their infrastructure as a service. Yes, we can discuss it, right? Hardware, so cloud vendor provide three services. So IaaS means infrastructure as a service, platform as a service, software as a. So desktop virtualization is a part of infrastructure as a service. Next use case, cloud computing. Virtualization, the foundation of cloud computing platform enables on-demand provisioning for virtual resources such as compute instances, storage, and networking. So, manki virtualization providing, so cloud platforms providing, enabling on-demand resources, on-demand provisioning virtual servers, right? So, In the EC2 console, we can create spot instances, unreserved instance, dedicated hosts. So on demand, when you create direct instance, it is taking as a on demand directly. So that is clearly seen in cloud computing. So despite the overhead introduced by virtualization, its benefits in terms of resource utilization, flexibility, scalability often outweighed the performance trade-off, making it valuable technology in various IT environments. So these are the benefits I'm saying, virtualization benefits. So these are the talking about virtualization completely. So what are the, so one benefit is server consolidation, next development testing, next disaster recovery and high availability, next high application support, legacy application support, desktop virtualization, and last one, cloud computing. So next disadvantages we talk. Now we are going to discuss about disadvantage of virtualization. So after deploying application, if you want to access hardware resources, you need to pass number of layers. That's why little bit latency is there. This is a primary disadvantages of virtualization. So it add complexity and overhead introducing by layers of abstraction, guest operating systems, and physical hardware. Application accessing number of layers. That's why it is a primary. Yes. Before container, this one is the best technology for application deployment. So next, each layer include hypervisor, any additional virtualization management software, and introduces latency and potential bottlenecks in access hardware resources such CPU, memory, storage, network devices, and that network devices means they're when you're building virtualization architecture, they're installing a lot of network related things such as drivers and all. And storage means how much storage if you if you need for our servers. So memory and CPU, what type of CPU you can choose and how much RAM I want to, this kind of analysis we need. So the layers all typically include guest OS. So now we're talking about guest OS. What is meant by guest OS? See, this is the guest OS. Each guest OS means guest operating system runs within its virtual machine. So with its own set of device drivers, kernel interacting with the hypervisor. So like that communication is there layer by layer. That is the guest OS activities. So hypervisor. Next we are talking about hypervisor. So hypervisor is nothing but hypervisor manages and arbitrates access to physical hardware resources. Translate hardware request from guest OS instructions that can be executed on underlying hardware. So whatever request coming from guest OS, all requests is translating to specific related OS and it is executed on underlying hardware. That kind of setup is maintaining hypervisor. Next, we we're going to discuss about device drivers. We cannot see device drivers. So because of hardware setup, hardware layer only, they are installed device drivers. Device drivers is nothing but virtualized device drivers within the guest OS. Translate hardware requests made by applications into instructions that can be hypervisor. Whatever request from guest OSs, each is translating to the hard. Each instruction can be understood by hypervisor. That request is hypervisor can understand saying this device drivers. Next, hardware abstraction layer. So short name is a hardware abstraction layer, hardware specific details. So allowing guest OS into interact with the virtualized hardware provided by the. So this layer and device driver is on, this is already set up background hardware section. Each layer add overhead in terms of CPU cycles, memory usage, IO operation, which can performance of the application running within the virtual machines. So this overhead is often referred to as a virtualization. So this is what all discussion virtualization advantage discipline which you use which each component we have discussed all. We discussed Docker and containerization technology. So now Docker lifecycle we can discuss. Docker lifecycle is a build, ship, run. So here what it means, build is nothing but Docker is commonly used during the build stage of SDLC to create lightweight, portable, reproducible development environment. So developers can define Docker files, which are text documents that specify the configuration dependencies required for their application to run. So this Docker file contains a lot of instructions. Each instruction is a specific use case. You need to follow those use cases. So practically, we are going to work on the files also. So these are the part of build. Files can use it to build Docker images, which encapsulate the application, its dependencies into single package. This ensures consistency across different development environments and makes it easy to